All right, let's talk about giving your programs a brain. Seriously, today we're going to build a decision-making toolkit for our Python code, and it all kicks off with one of the most powerful yet simple words in all of programming, if. So let's dive right in and see how this all works.
I mean, think about it for a second. How does a video game know you've just leveled up? Or how does a website know your password is the right one? It's not magic, right? It all boils down to this one simple question. How do programs actually make decisions? Well, turns out they're just really, really good at following the specific rules that we give them. And the big answer, well, it's the if statement. This is the first and honestly the most important tool we're going to put in our toolkit. The best way to think about it? It's like a fork in the road for your code. Your program gets to this point, looks at a condition, which is really just a simple question, and based on the answer, it decides which path to go down next. Simple as that. Okay, so where do we start? With the most basic decision any program can make. Just checking if two things are a perfect match. I mean, this is the foundation for everything. We're talking password checks, correct answers in a quiz game, you name it. Now this little guy, the double equals sign, is so important to get right. Here's the deal. A single equals sign, that's for assigning a value, like x equals 5. But a double equals sign, that's for asking a question. It's literally Python's way of asking, hey, is the thing on the left exactly the same as the thing on the right? And the only answer it'll ever give back is a simple true or false.
Let's look at a real example. So first, we set up a variable called car, and we give it the value BMW. Then our if statement kicks in and asks the question, is the value inside car exactly equal to BMW? Well, yeah, it is. So the answer is true. And the program does exactly what the indented line tells it to do. It prints the message. That's it. That's the core logic in action.
Okay, but here comes the first classic gotcha for pretty much everyone who starts coding. To us, BMW in all caps and BMW in lowercase, they're the same thing, right? Well, not to Python. To Python, those are two completely different things. And this case sensitivity can really trip you up if you're not paying attention.
And check this out. Here's the perfect way to fix that. On the left, you see the problem. The check fails because of the capital letters. But on the right, we use this super handy little trick, the dot lower method. All it does is temporarily convert the variable to all lowercase, just for the comparison. And just like that, our check works perfectly. It's such a simple way to make your code way more robust. Okay, so we know how to check if things are the same. But what about the opposite? What if we need to check if two things are not the same? Well, for that, we just add another tool to our kit, the inequality operator. It's just an exclamation mark right next to an equal sign. Take a look at this. We've got a variable, age, and we've set it to 16. The if statement then asks, is the value of age not equal to 18? And since 16 is, well, definitely not 18, the condition is true. And so our program goes ahead and prints that message for us. All right, let's keep building our toolkit. Making decisions isn't always just about equal or not equal. A lot of the time, especially when you're dealing with numbers, you need to know if a value is bigger or smaller, or maybe within a certain range. And the really good news here is that Python just uses the same symbols you learned back in math class. Greater than, less than, greater than or equal to, all that stuff. It makes the code super intuitive and really easy to read, which is awesome. Here's a perfect real-world example. So a student gets a score of 75. Our program's job is to figure out if they passed. So the if statement asks, are the marks greater than or equal to 50? Well, 75 is definitely bigger than 50, so that condition is true. And boom, the you pass message gets printed. Easy. Okay, now things are about to get really interesting. Because let's be honest, real-world decisions usually depend on more than just one thing, right? So how do we handle that in our code? We use a couple of special keywords that let us juggle multiple conditions at the same time. First up, we have the and keyword. The best way to think about and is to picture a really strict bouncer at a club. To get in, you need to be old enough, and you need to have your ID. If just one of those things isn't true, sorry, you're not getting in. With and, both conditions have to be true, no exceptions. And this breaks it down perfectly. So the code would look something like, if age greater than or equal to 18 and has ID. Python goes step by step. First, it checks the age. Let's say it's 20. Okay, that's true. Then it checks for an ID. Yep, that's true too. And because the thing on the left of the and is true, and the thing on the right is true, the entire condition is true. Entry allowed. Now, the partner to and or is way more laid back. Imagine you're checking for a discount. Maybe you get one if you're a student or if you're a senior citizen. You don't have to be both. With or, as long as just one of the conditions is true, the whole thing becomes true.
Okay, for our last set of tools, we're going to tackle a super common problem, checking if something is part of a larger group. You know, like, is a certain guest on the list? Is a particular item in stock? Python makes this stuff incredibly simple to do.
So just imagine this is our inventory. It's a simple Python list of the colors we have available: red, green, and blue. Now, a customer comes along and wants to know, do we have green?
And this is the tool for the job, the in keyword. What's so cool about this is that the code reads almost exactly like English, if green, in colors. Python just zips through the list, finds green, and because the answer to the question is true, it confirms the color is available. So clean.
Okay, let's flip that idea on its head. Sometimes you don't care if something is on a list, you need to know if it isn't. So here's a classic example, a list of banned users for a website.
So a user named Sarah tries to log in. Our program has to make a snap decision. Do we let her in? And to do that, it's got to answer this one crucial question. And this is exactly how it figures it out, using the not in operator. The code just asks if Sarah not in banned users. Python scans the banned list, sees her name isn't on it, so the condition evaluates to true. The result? Access granted. It's such a powerful and, again, super readable way to handle things like this.
And there you have it. In just a few minutes, we've put together a complete foundational toolkit for making smart decisions in Python. We went from simple comparisons to juggling multiple conditions at once. These really are the fundamental building blocks for making your programs feel alive and responsive. And get this, these exact same simple tools are at the heart of everything from a basic login screen all the way up to the complex decision-making you see in AI.
So that's the whole shebang. With these tools, you now have the power to guide your code, to make it react to different situations, and to build logic that feels genuinely intelligent. You've got the toolkit. So the only question left is, what are you going to build first?